In this question, it is given that a straight rod of length L extended from x is equal to a to x is equal to L plus a. Find the gravitational force it exert on a point mass m at x is equal to 0 if mass per unit length of rod is mu is equal to a plus b x square. So let's see first what do you mean by this mass per unit length. Mass per unit length represents the value of mass divided by length. Means if you are taking a small element, let's say of mass dm, so assume that we are having a rod something like this, and if I am just considering a small element over here, let's say its mass is dm and its length is dx. So mass per unit length means what is the mass of the small element by its length dx. So the value of dm by dx is going to be a plus b x square. That is the meaning of this term mass per unit length. So we are going to use this information in question. So just remember, what do you mean by mass per unit length? It is just mass divided by length. So according to the question, we need to find out what about the value of force between a point mass m and a rod whose mass per unit length is already given in question, and our aim is to find out what about the value of force of interaction between them. So we can just consider that there is a small element of mass dm over here, and we'll consider that this dm element is at a distance x from this mass m, and take it as this length of the small element is nothing but dx. So our aim is to find out the value of force of attraction between them. So what the other informations are given is distance from here to here is given as nothing but a, and length of this rod is given as nothing but L. So we can write, first we'll find out what about the value of force of attraction between this mass and small element dm. So which we can take it as g into m into dm divided by distance is x, so we can take it as x square. So you can write what about the value of net force is going to be integration of g into m into dm divided by x square. So we can write this is equal to g into m into, and in question already this value of dm by dx is also given. The value of dm by dx or mass per unit length is given as nothing but a plus b x square. So the value of dm can be written as a plus b x square into dx. Now we can put this value over here. So this is going to be a plus b x square into dx divided by x square. We need to integrate this particular expression. So and we can put the limit. The value of x is going to be changed from. So for this particular point the value of x is a, and for this particular point x is a plus L. So we can put the limit which is changing from a to a plus L. So we can just modify this equation. This is gm is basically constant, so we can just keep this constant outside the integration gm. Now it is integration of a divided by x square, a plus b x square divided by x square into dx, and the limit is changing from a to a plus L. So you can write this is equal to gm into a by x square can be written as ax raised to minus 2 plus bx square by x square can be written as b into dx, and the integration of this one from a to a plus L. So we can write this as gm into a is a constant, x raised to minus 2, the integration of x raised to minus 2 is x raised to minus 2 plus 1, that is x raised to minus 1 divided by minus 1 plus b dx integration is bx, and the limit is changing from 0 to or a to a plus L. So we can write this is equal to gm into a into, or you can take this negative sign outside, so we can write it as minus of a into 1 by 1 x raised to minus 1 can be written as 1 by x plus b into x, and the limit is changing from a to a plus L. So we can write this is equal to gm into minus of a into, now we are going to put the limit. We'll put the higher limit, that is a plus L, minus we'll put the lower limit, that is a, is equal to b into, we'll put the higher limit, that is a plus L, minus we'll put the lower limit, that is a. So this is going to be G into M into, and this minus A we can just write in terms of plus A. So this is A into, this term we can just reverse, that is minus A minus 1 divided by A plus L. So just to convert this negative into positive, we are just multiplying this negative over here. So it becomes minus 1 divided by L, and this becomes plus 1 by A, plus the value of B into, over here we know that we can cancel this A and this minus A. So this is going to be B into L. So this is the value for gravitational force of attraction.